my algebra students. We're going to start chapter 2. In chapter 2, we're going to start with writing equations. Let's remember, what is the difference between an expression versus an equation? Okay, let's remember those differences. First of all, this has an equal sign. This one has no equal sign. This one has a solution, or a solve, if you will. And this one has a simplify or an evaluate. Okay? You can have expressions and equations without variables, but you can also have them with variables. And when they have a variable in it, then we call them algebraic expressions, that's with a variable, or an algebraic equation is with a variable. So most of the time from here on out, when we talk about expressions and we talk about equations, we are going to assume that we're talking algebraic. All right, so how do you take words and make it into a math sentence? And remember, a math sentence has a complete thought. Okay? And that's what an equation has, a complete thought. An expression is a statement. So we're going to talk about equations today. So let me ask you again. How do you take words and make it into an equation? How do you take an algebraic sentence in words and make it into an algebraic equation using numbers and symbols and operations? Well, there are some words that give us direction of what we need to do. So that's part of what we need to talk about. What are those special words that lead us in the right direction? We have those algebraic sentences that are written in words, and we need to write them as symbols, numbers, and variables. That's really taking a real-life situation and bringing it into the classroom so we can manipulate it and talk about it. So what are some of the words that lead us in the right direction? Sum, difference, product, is, more, less, times, quotient. This is just to name a few. So when you're reading words, you need to be able to take that and understand that we are going to write that as a math sentence, which is an equation. Okay, the first couple examples that we are going to work through are just going to be taking sentences and writing them as algebraic sentences. We are not going to worry about solving them because as you read these, as I read them to you, there are more than one unknown in each of them. And right now, because of only writing one algebraic equation, we cannot solve when there's more than one unknown. So let's look at example 1. Example 1 says a number b divided by 3 is less than 6. So you'll notice that I paused every time I was reading because you have a number b divided by, and it's divided by what? Divided by 3 is, and then we have 6 less than c. So you'll notice that I have 4 parts, and the first one that I can really take care of is the is. So let's see what goes on the left side of the is. I have a number b divided by 3. So I have a number b divided by 3. Now, this is one way of writing it. Okay, some of you might have gone ahead and thought of it this way. That's not wrong, but it's also not as proper as we want to be now in algebra. So let's forgo the division sign and remember that I can write division as a ratio of 2 integers. Okay? All right. So now I have a number b and then divided by 3. So number b is up on top, divided by 3 is my bottom, is, which is equals, and then it says 6 less than c. Ooh. So, do I have something? This is probably the most difficult because if you read it and you just write it down, you would think it would be 6 and then less than means subtraction than c. But let me read it to you differently. I have c and the value over here is 6 less than c. So what did I start with? I started with c, and what did I have to do to c to get this squiggly part? I had to get rid of 6. So to get rid of 6, I subtract it. So again, a number b divided by 3 is, I have c and I have 6 less than that, so I got to take 6 away from my c. This would be taking my sentence and writing it as an algebraic equation. So let's go to number 2. Number 2 says 15 more than z times 6 is 11 less than y times 2. That's a lot of things going on. So let's see. 15 more than z times 6. Ooh, that's something with something else. So that's like a layer in a layer. So this word right here is a transition word. This right here is transition. So I have 15 more than. So did I have something and I gave 15 to it? Or did I have 15 and I gave something to it? Let's read and see. 15 more than. Well, to me it sounds like I had something and then I added 15 to it. So that's this part right here. I just don't know what I'm going to put here yet. So let's keep reading. 15 more than, ooh, more than what? Z times 6. So I added 15 to the, ooh, times means product, to the product of z times 6. How do I write z times 6? It looks like this, but now that we're in algebra, we write it with the coefficient first, so it'll be 6z. So let's read that sentence again. 15 more than, so I added 15. What did I add it to? I added it to z times 6, so 6z. And then I have the word is, transition word, is means equal. And what is it equal to? 11 less than, ooh, so I had something, but it's not quite the same. It's 11 less than it. So I'm going to subtract 11. And what am I going to subtract 11 from? I'm going to subtract it from y times 2. How do we write y times 2? That would be 2y. So let's read it. 15 more than, so 15 more than, that's my addition. Then what? Then z times 6, so that'd be 6z, is, that's my equals. 11 less than, that means I'm taking 11 away from something. What am I taking it away from? I'm taking it away from y times 2, which would be 2y. Why is it necessary that we know how to take a sentence and write it into an algebraic equation? Well, we use that every day when we're talking situational mathematics. For example, if I tell you that the length of my room is 3 more than my width, and my area is 216 square feet, Do you know how to set that up? Well, what is the shape of my room? Yep, my room is a rectangle then. So I have this rectangle, and I had length and I had width. And my length and my width are different because I said my length is 3 more than my width. So instead of using 2 variables, I could use 1 variable, and I could say, well, my length is equal to my width plus 3. Because I said that my length was 3 more than my width. So now instead of writing it length times width, I could write it width and then width plus 3. And then I told you that my area had a value. Well, how do you know how to find the area of a rectangle? Well, I hope you all remember a formula. And the formula for area of a rectangle is length times width. But in this case, my length is W plus 3, and my width is W, and then whatever my numerical value was, and I think it was 200 something, maybe it was 218. And that, I just rewrote the formula using the measurements that I was given. Well, let me go a step further and say, all right, how would you say that to me? 2L plus 2W equals 72. What does that mean? How would you explain what that means to me? Well, there's 3 things. There's a situation. I have a transition. A situation, a transition, and I have a situation. So how could you write this using words then? Well, the first situation, that's a product. So that would be the product of 2 and L. And then what's this situation? Well, this situation is the product of 2 and W. And then what is this transition here? That is a is. And then this guy right here is just a number, and it would be 72. So now let's figure out how I write that as a complete sentence. I have the product of 2 and L, and what happened to that product? Transition. It was added with, or added to, or another way of writing it is the sum of. So let's use that one. The sum of the product of 2 and L and, watch this, the product of 2 and W, let's pick this word up, is, and what is it? It's 72. So the sum, which is that transition, of this part, 2 and L, and the product of 2 and W, transition, is 72. All right, you notice that I have 2 examples up here, and let's do one at a time. So number 1, this says 12 minus 2x is equal to negative 5. So now we have to talk about relationships. You have a transition and you have a transition. Between those transitions right here, you have two situations that have occurred. 12 isn't easy because it's just a value, but this guy right here is a little more difficult. You have to talk about that one, and you can't just say 2x. What is 2x? 2x is a product. You can either say the product of 2 and x, or you could say 2 times x, or you could say x times 2. Wow! So I could do the product of 2 and x, or I could do 2 times x, or I could do x times 2. How do I decide? It's comfort. That's how I decide. So these right here deal with this relationship here, which is 2x. So what am I going to do? I'm going to say minus can be less than. So I'm going to say, I don't even know if I like less than. Maybe I want to do difference. Ooh, wow, there's so many choices. So maybe I'm going to do this. The difference of 12 and the product of 2 and x. So that gives me this right here. And then this transition is. And what is it? It's 15. I think I like that better. Yours might be different. So number 1 is that sentence right there.